In this problem, we are told that a positive 7 nanocoulomb charge is located at the origin. We are to find the magnitude and direction of the electric field caused by that charge at x equals 5 centimeters. So we want to start by drawing a diagram of what's going on. Here's 5 centimeters out. There is a charge located at the origin. So I'll draw a little dot representing the charge. I'll label this as Q7 because the charge is 7 nanocoulombs. We want to find what is the electric field at this spot. Now there is not a charge at that location, but that does not mean that a signal does not exist. Remember, the electric field is like a signal that is sent from one charge. So we are to find how much of a signal is at this spot, even if nothing is located there. Now we are given the charge and the distance from the charge. So we had two equations for an electric field. I'll just jot them down here. Since we are given the charge and the distance, we want to use the first equation instead of the second equation. We're not given the electric force at all. So our equation, electric field, is KQ over R squared. And now we can put in our values. Now remember that K is 8.99 times 10 to the 9th newtons times meter squared over Coulomb squared. It is Coulomb's constant. Q is the charge, but we need to make sure that we are in regular coulombs. So a nanocoulomb means times 10 to the negative 9th. Remember, nano is negative 9. You got that alliteration, hopefully, to help you out in remembering. Divided by the distance we are from that charge squared. So we are here 5 centimeters from the charge. But we need to convert that into meters. So we say it's 0.05 meters, and that distance is squared. That means that our answer comes out to be that the electric field is 25,172 units or newtons per coulomb, but we need a direction. It says magnitude and direction because the electric field is a vector. Now we have learned earlier that the electric fields point away from positive and towards negative. So since this is a positive charge, the electric field at this spot points away from it. So if I'm going to stand here at the X marks the spot, and I want to draw an arrow pointing away from the positive, I would draw an arrow to the right. That arrow is now pointing away from the positive charge. So the direction of the electric field at that location is 25,172 units per coulomb, which is the magnitude, and to the right, which is the direction.